All right, well, thank you everyone. So I'm going to talk about some of the final results for my PhD, and this is my last protocol, so I am pretty excited for that. Because that means this is going to finish, not because I don't like it. Well, just as a background, there are two main scenarios that have been proposed of how basal sauropodomorphs, or how sauropods evolved, the quadrupedality and their giantism, which characterizes them. The first scenario is basically this one that says that they started as bipedal animals, and eventually one of the lineages just started to adapt, to create the morphological adaptations for quadrupedalism. So under this model, quadrupedality originated once. The second model is that quadrupedality was acquired in a stepwise fashion. So you have bipedal, then less bipedal, then more quadrupedal, and then finally obligate quadrupedalism establishes. It doesn't really matter how much you vary your parameters with each data set or how much to change the implied weighting or anything. You cannot make the data set from scenario 1 to produce the data set in scenario 2. However, when you do Templeton test of one scenario with the data set of the other one, it's equally likely, but you just don't get the trees. So my PhD moved from understanding how quadrupedality evolved to trying to sort out why are we having this incongruence between the phylogenies. There has been proposed character selection, character coding, and taxa sampling as the main candidates for being the problem. Also, it's been argued that a supermatrix approach, which is also called total evidence, which put all of the information possible and currently available, that helps you to prevent the three main problems, character selection, coding, and taxa sampling. However, there is one for candidate that is really difficult to assess, and it's called character delineation. And the thing is, so far there is no way to compare the characters in one data set with the characters in the other data set, because usually they are formulated differently, and sometimes you're not sure if one character is actually conveying the same information than other character. So I started to dissect the data matrix that I got. And first is the operational taxonomic units. So the first thing that I started to see is if there was any sampling bias. First of all, if you take all of the basal sauropodomorphs and you split them between the ones collected from Gondwana and Laurasia, what you see is that the sampling effort on Gondwana has increased, but overall you have the same proportion of Gondwanan specimens and Laurasian specimens. When you go to the phylogenies, you notice that there is a slight trend to oversample Gondwanan specimens. And in Gondwana you have the basal most forms. So if you're including the basal most forms with the more derived ones, the chances to get a gradual thing increase. So the stepwise, the scenario could just be an effect of oversampling basal forms. Then, the way the information is being incorporated into the data sets is not done on an accumulative way. So on the left panel, you have all of the species that have been available since phylogenetic analysis started to be applied on basal sauropodomorphs. And as you can see, you would expect that these ones that have always been available because they have good monographs, they have pictures, and they are in public collections, only one of them has been used in all of the analyses. The rest of them varies. And then you have ones that have been not always used. And with the new ones, you would expect that at least the new findings get incorporated into data sets. But then you have that even the new ones, the newest ones that were produced 2 years ago, are not used for the new genetic analysis that are produced after that discovery. So there is not a gradual adding of the information, and that means that all of the data sets in the end are completely incompatible. Finally, missing data, whether it plays or not a huge impact on the phylogenetic analysis, the problem at hand is that basal sauropodomorphs have a lot of missing data, and this is plotting the amount of missing data, the amount of characters that you have from the cranial region, from the axial region, and from the appendicular region. And although you have some of them that are more or less complete, you have a lot of missing information. And also there is a lot of focus on the appendicular characters. And there is a lot of neglect, the people is neglecting a lot the vertebral characters. So that's for taxa. I forgot to mention here that I ended up splitting into taxa all of the divisions that were done based on a phylogenetic analysis. So it is that if two species were merged together because they were clustered together in the phylogenetic analysis, I separated them because there could be a bias in the dataset used for that splitting. So that increased my number of taxa. The second part is when you start to evaluate the character statements. What I mean with character formulation is basically to make sure that your character has a main locator, a secondary locator, a variable, there is a qualifier for that variable, and that you have pretty easy to recognize variants. So I decided to give it a go on how to assess character information. So basically we can think that we have two kinds of characters. We have neomorphic characters, which is when this is using a mathematical tool called topology, which is the study of forms. And for a topological mathematician, a mog and a torus are the same figure because you can deform one into the other just using mathematical functions. So the donut and the mog are basically the same shape. So if you use that to assess how much information a character is conveying, you end up having neomorphic characters, which are the ones when you modify from a surface to a sphere, to a torus, to a double ring, and you have homeomorphic characters, which are characters that you just have to deform. So where there are deformations, either elongations, change of shapes, etc. And then characters can then have 6 independent modifications, and these are modifications that do not depend on the other modification. So you can modify the orientation without affecting the location in a mathematical point of view, the number, the shape, the connection, and the size. So using the criteria that one character should be conveying information from one of these categories would indicate that that character is probably operational. And that means that you can apply it easily. So I have come up with a jet new metric to compare matrices. And what you're seeing there is a breakdown of all of the categories, topological categories, and how many characters fall in those categories. So if each character is conveying information from one independent change, you will have a 100 adding up. None of the matrices add 100. So that means that you have a lot of characters that could be ambiguous. And that means that as you increase the amount of taxa, the probability of finding one taxon that is not scorable or that you cannot score increases. So that makes the character more ambiguous. And when I flagged the characters in one of the most recent phylogenies, when I flagged all of the characters that were redundant, all of a sudden the topology, the main topology disappears. And when you delete characters and random, the same amount of characters, the main topology is preserved. So that means that the characters that are being ambiguous are introducing a noise, and the variability they are trying to convey is not being perfectly sampled or perfectly scored in the tree. So that's, I also did partition analysis, which is having your data set and see how the information from the head, information from the vertebral column, and information from the limbs compares to each other, and also split the characters between discrete and continuous versions. I'm not going to put trees because putting trees in slides is really difficult. So main remarks is that if you just use the skull of ornithischians, sauropodomorphs, and theropods, you get Phytodinosauria, which is a cluster of ornithischians and sauropodomorphs. That's probably because we have too many characters relating to feeding habits. If you use the actual partition, then you get Sauriscia and Ornithischia, because you're including all of the pneumaticity characters from the vertebral column. If you use the appendicular partition, then all of these scenarios become equally likely for dinosaur evolution. And using 924 characters optimized with the topological framework, which doesn't modify the character coding that you use. So if it's reductive, if it's non-reductive, multi-state character, the topological framework doesn't bother with that. It's just assessing the categories. So this is the complete phylogeny with 924 characters, the largest data matrix for basal sauropodomorphs, and the story is that you do have one lineage that acquired quadrupedality and that gave rise to sauropods, then another experience with quadrupedality, and then a reversal to bipedality again. So the history that they could be conveying is actually more and more complicated than we thought, and none of the two scenarios that I showed you at the beginning are hold true. For the continuous characters, I had to get rid of most of them. I had to get rid of them from the phylogeny because it needs to be assessed whether the character is valid or not. And in here you're seeing that if you have, I have 257 characters that are continuous, and they're done discretized, which is you choose which values are 0 and which values are 1. And if you use frequency densities, it is really difficult to justify those divisions in some cases. And also there is a lot of correlation. So in here you're seeing all of the correlation of the characters of the ilium. The ilium is the bone that usually has more continuous characters in this group of dinosaurs. And it should be color-coded, but it's not. But most of that is coded in red because a lot of these characters are covariant each other. So you are introducing a lot of redundant information. Other characters, when you divide them, for instance, in this one, if you code this character, that line is your arbitrary division. So you can put a line basically wherever you want, and then you will choose which taxon is going to be where. They are actually conveying more and more information. And basically, if you see all of the quadrupeds, as you get larger, if you go above the average, you can diagnose quadrupedality from bipedality. So my conclusions, which are more like new hypotheses that I have, is that comparative cladistics suggest that none of these scenarios is better than the other one for the evolution of basal sauropodomorphs, that the root of incongruences is actually related to the way characters are delineated and how they are becoming operational, that missing data, if it's having an impact, is because we have a lot of inoperative characters. The supermatrix approach actually helps to solve the problem, and the take-home message is that character formulation and character delineation need to be carefully assessed before the scoring, and it's something that hasn't been done for dinosaur phylogenies. And that's my talk.